Welcome to qnawire.
Hi. So in the problem, we are given that a budding electronic hobbyist, he wants to make a simpler 1 nanofarad capacitor for tuning her crystal radio using 2 sheets of aluminum foil as plates, as the parallel plates. So basically, she wants to make a parallel plate capacitor and with paper as the dielectric material in between the parallel plates. So the paper she is using as a dielectric material. So it's given that the dielectric constant of the paper is 3. So the paper has a dielectric constant of 3. It's given to us. And what else? The thickness of each sheet of paper, let's call it as small t, is given to be 0.2 millimeters, or in terms of meter, it's 0.2 times 10 raised to negative 3 meters. Now, in the first part of the problem, we are being asked if the sheets of paper measure 22 by 28 centimeter. So if the sheets of paper measure 22 by 28 centimeter, and she cuts the aluminum foil to the same dimensions as the sheet of paper, so how many sheets of paper does she need with the plates to get the proper capacitance, that is the capacitance of 1 nanofarad? So before calculating the capacitance, or the number of sheets needed, let us calculate the area of the aluminum foil. So it's given that the dimension of aluminum foil which she has cut is same as the dimension of the paper, which is going to be 22 by 28 centimeter. So if I want to calculate the area, it will be 22 times 28 centimeters square. So in terms of meter, it's going to be 10 to the power of 10 raised to negative 4 meters square. And this area comes out to be around 616 10 raised to negative 4 meters square. So this is the area of the aluminum foil. Now, the distance between the parallel plates can be written as, so distance is going to be some number of sheets of paper she's going to use times the thickness of each sheet. So that's going to be our distance between the parallel plates. And for parallel plate capacitor, we already know the capacitance C is given by K times, the K is the dielectric constant, K times epsilon naught A over D, where D is, in our case, is N times T, and is the number of paper sheets, and T is the thickness of each sheet of paper. So since we need to find the number of papers needed, so from this we can find N equals K epsilon naught A over C times T. So this is the formula which we are going to use to find the number of sheets of paper which she should use to get 1 nanofarad capacitor. So if I substitute the values, so N equals K, K is going to be 3, epsilon naught as usual 8.85 times 10 raised to negative 12, and area which we have calculated to be 616 times 10 raised to negative 4 divided by the capacitance, which is the required capacitance is 1 nanofarad. So I'm going to write 1 times 10 raised to negative 9 farad capacitance times the thickness, which is 0.2 times 10 raised to negative 3. And if you do this calculation, the number of paper sheets she needs comes out to be around, so you will get a non-integer number. So taking the nearest integer of that non-integer number, it comes out to be around 8. So she needs 8 sheets of paper in between the aluminum foils to make a 1 nanofarad capacitor. So this is the answer, first part of the problem. Now moving ahead, in the second part, we asked, suppose for convenience, she wants to use a single sheet of poster board instead of multiple sheets of paper with the same dielectric constant but a thickness of 12 mm. So now she wants to use a single piece of poster board with the same dielectric constant as 3, and in this case the thickness is 12 mm. So since she is using a single poster board, the thickness equals to distance between the parallel plates. It is 12 mm here, so it's 12 times 10 raised to negative 3 meter. That's the distance between parallel plates. And instead of paper, she's using the poster board of this thickness. Now we are required to find the area of the aluminum foil which she will need for her plates to get 1 nanofarad capacitor. So again, using the formula C equals K epsilon naught A over D. So in this case, we need to find the area. So our area is going to be capacitance C times T divided by K epsilon naught. So this is the area which we need to calculate. C capacitance times the distance between the plates divided by dielectric constant K times epsilon naught. So substituting the values. So the capacitance which we require is 1 nanofarad. So it's 1 times 10 raised to negative 9. And what else we have? The D, the thickness is given to be 12 mm or 12 times 10 raised to negative 3 divided by K. K is 3 itself times epsilon naught. Epsilon naught is 8.85 times 10 raised to negative 12. So if you do this calculation, we'll get that the value for the area needed is going to be comes out to be, so the value for the area comes out to be around 0.45 meter cube. So this is the answer for the second part of the problem. In the third part, it is mentioned that suppose she goes high tech and finds a sheet of Teflon, which is a perfect insulator or a dielectric for making a capacitor. She finds a Teflon of the same thickness as the poster board to use a dielectric. Now in this case, will she need a larger or smaller area of Teflon than a poster board? So if you see for the third part of the problem, since she's using, so instead of a poster board, she's going to use Teflon of the same thickness. She's going to use the Teflon of the same thickness. So, but in this case, if you look at the formula for the area, so it's C times T divided by K epsilon. So area is C T divided by K epsilon naught. So now the dielectric constant of Teflon is greater than, so if I write like this, the dielectric constant of Teflon is greater than that of the dielectric constant of the poster board. Let's say PV poster board. So as you can see from the formula for area, if the dielectric constant for Teflon is greater, then the area needed for Teflon is going to be less than the area needed for the poster board. It is quite apparent from this formula. So since K, the dielectric constant, comes in the denominator, and it is greater for Teflon. So area needed will be lesser. So this is the, for part C, we need the smaller area of Teflon than a poster board, and we have already given the explanation. It's because of this formula. With this, we conclude the problem, and thank you very much.